Hi, everyone. So we are at the last lesson of this quarter. What? So we're still on lesson 3. I want to say lesson 3. Yep, no, lesson 2, sorry. Lesson 2, fun with functions, linear ones. And we are on this page right here, M226, which is in your regular book. And here, a local pet store has a fish tank on display at the community fair. Darren is responsible for draining the tank at the end of the fair. The pet store manager provides him with this information when they drained the tank at the end of the fair last year. So last year, they after 15 minutes. How do I know that's 15 minutes? It's 1/4, right? So 1/4 of an hour, 15 minutes. It was at 169 gallons. That's how much it remained. And after half an hour, right, that would be 163, and so on and so forth. And so we notice right here, oh, well, first, a couple patterns that I notice is we go up by 1/4 of an hour every time, right? So every 15 minutes, that seems to be the increments. And here, every 15 minutes, what are we're decreasing by 6. And so now the question is, how many gallons does the fish tank hold? So altogether. And so if you notice right here, I'm going to use pink to kind of indicate what I'm doing here right now. If we're going down by 6 every 15 minutes, so basically we're going back in time. So we're adding those 6 gallons back in. So that's what we have plus 6 right here, because we're adding it back in. So this would have been 175. It's because 175 minus 6 would give us that 169. All right, and that would be at time 0. So right, like when the tank was full. Okay, so that's 175 gallons. It says, when will the tank be empty? Now we could keep on making this chart until we get to 0, right? So once this is 0, that's when whatever this time is going to be, right? I don't know what that time is. So, but we could continue to do that, keep on subtracting 6 every single time. Or we can make an equation, which would be a little bit easier. Now, the reason why we got the way we got, so this is the slope, but remember it's going to be, we're going -6, we're losing 6 gallons every 15 minutes, right? So we don't want it per minute. We want to know how much it is per hour, right? Because it looks like it's going to take a long time. So per hour, so for 1 hour, what's it going to be? An easy way to do that is just, well, how many minutes go into an hour? 15 minutes go into an hour. 4 of them, right? So this is literally times 4, and we're going to multiply this by 4. And what do we get? -6 times 4, which is -24. This is -24 gallons per 1 hour. Or we could just count right here. Some people did this where they went to 1 hour. So from here, 0 to 1 hour. That was from 175 to 151, which is going to be what? 24 gallons. Okay, that's another way to do it. Okay, a lot of different ways to think about it. And some other people did, well, -6 minus 6 minus 6 minus 6. We did that 4 times. So it's -6 times 4, which is -24. Either way is okay. So here we go. Notice right here that the slope is negative because we keep on subtracting. If you notice the pattern, we are subtracting. So it should be negative. So there's -24 x, and then this is our initial amount. So this is how much we start with. So that's going to be our 175, which we got from up here. All right, that's our initial amount. And so we want to know, when will the tank be empty? So again, just like this, our y, when will our y be 0? So this is why we put in the 0 right there. And we're just going to solve for x. Now, if you confused as to what is y and what is x, always look at the table right here. The table tells us what our time is, right? Which makes sense, because -24 times what? Times the number of hours, right? If we're draining for 1 hour, how many gallons is left? Well, -24. 24 gallons were drained out, right? If it was for 2 hours, then what would it be? 2 times -24, which would be 48, right? So that this is x represents the time, or so the number of hours that we're draining this for, right? There we go. So x is always going to be our time right over here, and then y is going to be the stuff on the right-hand side, which is our y, which is the amount of water remaining. And so we want the amount of water remaining to be 0. So that's why we plugged in 0 for y. And then from here, we're just doing some simple solve for x kind of things. So subtract 175 on both sides. And then we just get 0 minus 175, which is negative 175, is equal to negative 24x. And then we're just dividing both sides by negative 24 to get 7.29. So we're going to answer the question, and the tank will be empty after 7.29 hours. So probably less. 29 is about a third of an hour, right? So if it's a third of an hour, that's like 20 minutes. So 7 hours and 20 minutes around there. So he's going to be waiting for a long time. So he could probably just like drain it and then go and come back. I don't know, right? What are you going to do for 7 hours? Just watch it slowly drain. Well, at least you get paid for it, right? And so there we go. Now we're on to a new scenario. This is with Marilyn, who sells silk screened t-shirts, right, for her mom at local festivals. So after each festival, she returns whatever money she earns to her mom. She's a very honest person here. I'm sure her mom will split it with her, right? I give her a certain percentage. The graph shown represents her total, her potential earnings based on the number of t-shirts she sells, which makes sense. You sell more t-shirts, that means you're going to make more money, right? And so if you look right here, a couple of different things. If we see the origin right here, that is talking about what? What does this origin mean? Origin is just the 0, 0. So it just means that we're going to, if you sell no t-shirts, we're making no money, right? That's just the way it goes, right? And if we're going to sell, like, let's say 1 t-shirt, well, how much would that be? You notice that this is at 50. So it looks like each of these little tick marks it represents $10. So this is going to be about 15 bucks. And if you look at 2 t-shirts, how much do we get? Oh, this is going to lead, this is like 30 bucks right here. All right. And you can go on, if I want to know how much it would be for 4 t-shirts, that is right here, 60 bucks, right? So we don't change the price of the t-shirts. It's always going to be the same. So every single t-shirt is 15 bucks. Straight, makes it easy for calculations, right? So if you notice right here, the labels, potential earnings is for the y-axis, and the number of t-shirts, I should say the number of t-shirts sold, right, is going to be for, what is it, the x-axis. All right, and we've already talked about the interpretation of the origin. Somebody said in class, no shirt, no money, right? So you don't sell any t-shirts, you don't get no money. All right, and so the way we would do that is, so it says write a function e of t. So remember, this is, we call this e of t, which is, I wrote it down here, which is basically say, so what is our earnings based on the number of t-shirts we sell? So that's what e of t stands for. All right, and to model Marilyn's potential earnings given the number of t-shirts she sells. So we know that her earnings based on the number of t-shirts she sells is equal to 15 times t, because each t-shirt is 15 bucks, right? And times t, which t is the number of t-shirts she sells, right? And then why is it plus 0? Because if she gets, what's her initial amount of earnings? 0. She doesn't get anything. If she sells nothing, she doesn't get any money. So that's why it's just plus 0, or we would just say this. This is the preferred way. If you write it this way, I know you mean plus 0, right? Some people, I think, are unsure. Like maybe the teacher doesn't know what I mean by that. I do. No worries. And just as a quick reminder, just remember that y is equal to the e of t. So if you say e of t, we're not saying e times t. That is completely different. So this is in function notation. So where instead of y, we just say e of t. This makes it, the reason why we do that is to be a little more specific as to what kind of y we're talking about. We're looking at this e for earnings. So it could have been p for profit, you know, but we're just going e for earnings because that's what they said. All right, so now what does e of t represent in terms of the function and the graph? So remember, t is in the x position. So this is the number of t-shirts sold. E of t, remember, it represents the y, right? So that's our potential earnings based on the number of t-shirts we sell, right? So what does the y depend on? The x, right? So the e depends on the t, and that's where the t is right here, okay? Hopefully that's a little, I know it's a little weird sometimes, but, and so the way we could relabel these graphs is instead of saying x, we could say t, and instead of y, we could say e of t, okay? They're interchangeable. They are the same thing. They represent the same thing. So evaluate each equation just by looking at the graph. So we don't even have to plug it into the equation. We can just do it by looking at the graph. So what does E of 2 mean? It's basically, remember 2 is where the T used to be, right? Is that tricky? Which means how much would we earn if we sell 2 t-shirts, right? So we go over here to 2 t-shirts and we're like, 30 bucks. See, easy. So the way we would write that is E of 2 is equal to 30, which means when she sells 2 t-shirts, she earns 30 bucks. See how that goes? Okay. So literally, like if we look at it from the graph's point of view, if we just still label this X and Y. So when X is equal to 2, Y is equal to, Y is equal to 30 for this graph. Is that always going to be true? Well, if you change the graph, no, it won't be. So, but looking at this graph, that is true. Okay, so we're looking, this is our reference point. And if you're wondering where I got this graph from, I just clipped it from the top, from the previous page. All right, and then E of 5. So you're looking for when T is equal to 5, what is the earnings? And that's going to be $75, right? So E of 5 is equal to 75. So basically when she sells 5 t-shirts, she earns 75 bucks, right? And then, okay, E of 2.75, this is weird. So we go to 2 and a little bit more, like close to 3. So we land right about there at 40. So what does that mean? When she sells 2.75 shirts, she earns 40 bucks, which is weird. Is that something that we would normally do? No, like we wouldn't normally do that. But in different situations, right? If the X was talking about something other than t-shirts, if it was something talking about like, I don't know, parts of the day or time of day or something like that, that would work. Or the number of hours or something to that effect. Yeah, that would work. But in this case, our x-axis represents the number of t-shirts. This is discrete, actually. So we should not represent it with a line. We should represent it with dots. But there's that. So, so it says right here. So Marilyn has a goal to earn 100 bucks at the festival. Let's consider how to determine the number of t-shirts she needs to sell to meet her goal. So if you notice right here, to determine the number of t-shirts sales it takes to earn $100 using the function, there's the function that we had, right? Substitute 100 for E of T. Now, why would we substitute it for E of T? Because remember, that represents your earnings, right? So earnings depending on the number of t-shirts you sell, right? So there we go, earnings. So 100, and then we're just going to sell for T. So basically, you're just going to divide both sides by 15. And you get 6.67. Now, what in the world does that mean? So to earn $100, she needs to sell 6.67 shirts. So we know we can't. So I think the better way to say this is maybe saying at least $100, because we know if she sells only six shirts, did she make $100? No. If she sells 7 shirts, did she make $100? Well, no, but she went over it, right? Which is preferred, right? At least she met it, right? She met that goal and exceeded, right? So, so I would say to her, you need to sell 7 shirts. That's what you need. That's your goal. Because if you say you need to sell 6 shirts, she never actually gets to 100, right? So you don't want to do that. All right. So why can you? Okay. So we talked about this one already. It's the earnings. And we skipped this just a little bit, and we're going to go on to this one. So Marilyn's mom has a great idea. She's like, well, why don't we do a raffle? So we're going to give away 3 t-shirts, not at the same time, probably to like 3 different people, right? But we're going to do a raffle so they can buy some raffle tickets. But we're not including that in part of the t-shirt sales because that's not actually part of the t-shirt sales. Those are raffle tickets, right? So, or maybe it's not even raffle tickets. Maybe it's just put your name in here and then we'll just draw out a business card or your name or whatever, right? So here, so now we're introduced. So this was our original. The black line is our original line, right? The one that we just saw, E of T. Now we're given this G of T, right? Where it's talking about, like I'm going to say G is for giveaway, right? Because we're actually giving 3 t-shirts away, right? Now, why does it go all the way down here? Why is it shifted down? It looks exactly as it is, like shifted down. Why is that? Because what if we sell no t-shirts, but we give away those 3 shirts? How much money did we make? We actually made, because you remember each t-shirt is 15 bucks, right? So 15 times 3, that's 45. So we're actually $45 in debt. Like we're in the hole $45, right? Because we didn't sell anything, but we gave away 3 t-shirts. So we didn't earn those $45. So yeah, that's why we're down $45. So if we want to make that up, well, how many t-shirts do we need to sell? That's where this is. So we'll get to that. We're not there yet. So how do the graphs show the selling price per t-shirt remains the same? Well, how do we know that? And a lot of people say, well, they look the same. Well, what does that mean? And they're parallel. So if we talk about if they're parallel or whatever, that's talking about the slope, right? How tilted is the slope? So that slope remains the same, which shows that's our average rate of change. So it keeps on going up $15 for every 1 shirt we sell, right? So let's see, we start here, we go up 15. So here's 10, 15 is right here. See how we land on the line again for every 1 shirt we sell. So here's another $15, another 1 shirt we sell, another $15, another $15, 1 shirt we sell right there, right? Same thing with this one. We start at 0, 0. We go up $15 and then go over 1 t-shirt. Up $15 over 1 t-shirt. So so the slope is the same. The rate that we're charging, same. It's not different. So we know that because they have the same slope. It is parallel. Okay. I should say parallel lines. I'll change the color here. Did you know that the word parallel has 2 parallel lines? Well, technically 3, but these 2 right here, parallel. I don't know if they knew that when doing that, but I noticed that. So it says, what is G of 0? Okay, G of 0 is this part right here. This right here is G of 0 is equal to what? Negative 45. Because what does that mean? When you sell no t-shirts, that's your 0 right here. When you sell no t-shirts, how much do we earn? Negative $45. So we're in the whole 45 bucks, bad days. Okay, and then if you look at C, now it's a little bit different. Notice where the 0 is. Now it says G of T is equal to 0. Where is that? This is where G of T is equal to 0. Right here, because you notice for the y-axis, we're at 0. So what is that T equal to? That T is equal to 3, right? Which means we need to sell 3 t-shirts in order to break even, right? In order to make no money, right? We didn't lose money, but then we didn't make money either, right? So we need to sell at least 3 t-shirts. But hopefully because that raffle will sell more, right? That's the hope and that's the goal. So basically, again, I wrote it right here, need to sell 3 t-shirts to make $0 to break even, we would say. So here, we're just going to take a look at these 2 guys right here, Michelle and Myra. So Michelle says, Marilyn is giving away 3 t-shirts, so she has 3 fewer t-shirts to sell. So she wrote it like this. I'm like, okay, that makes sense. Here, this is t-shirts she can sell. So remember, we don't have like an infinite supply of t-shirts, right? We have a limited amount, but whatever she has minus 3 of them because that's the number of t-shirts she can sell. Okay, because we gave 3 of them away, so 3 of them we can't sell those because we have to give those away, right? And then here the $15. This is like the how much we charge, right? It's $15 per shirt. And then Myra says, well, instead of doing it that way, this is just the number of t-shirts she sells. She's focused more on how much we can make. So this is t-shirts we have. And then we're going to times that by 50 and we're going to take away, this is how much it's going to cost us. To give away those t-shirts. Or how much that affects our earnings, right? It affects it, we lose $45 in potential earnings, right? I should probably say that. So verify that these 2 equations are equivalent. Are they the same? Let's find out. So we're going to find out here. So we got 15 times t minus 3. Well, I know I want to see if it is equal to 15t minus 45. Is that the same? I put a little question mark over because I'm not sure. We're trying to verify that, right? So I'm like, oh, I know how to get rid of these parentheses, right? I could just distribute. So 15 times t is 15t minus 15 times 3, which is 45. And if you look, I'm like, oh, that's the exact same thing, right? So yeah, we know they are the exact same thing. Check, done. All right, we are going to actually, let's see if I, yep, no, I think that's about it. I would like to, well, I would do this part right here, just as a quick review of things. It says, okay, well, let's figure out what the equation is. So we are on page 36 right now. So if we know, so notice we're going, x is going up by ones every single time. So this is good. This is just like our sequences, right? Arithmetic sequence. And let's see what this is doing. This should be going up by the same amount as well. It looks like it's going up. So this is going to be from negative 20 to 5. That's going to be 25 at 25. This is also plus 25. Yep, plus 25, plus 25. Okay, so that's good. So we know it's going to be 25 over 1, which is just 25. So our slope is equal to 25. I'll just say over 1, which is 25. And what do we start with? Well, what is it at 0? So if we were going to predict that, so if it's at 0, we're just adding this in there. So remember, we're adding 25 going to the right. So if we go to the left, we're like subtracting 25. So this would be negative 45. So our function would be f of x is equal to 25x minus 45. So it's kind of like what we talked about before, where we give away. So we're giving away $45 of something, worth of something, right? And $25 is how much we're earning for every t-shirt or whatever it is that we're selling, right? So we're getting that much every single time we sell the thing that we're selling, right? Whatever that is. And so here it is. Well, what is f of 12? Remember, 12 is in the x's position. So we're just going to plug in 25 times, this is minus 45. So instead of x, what are we going to put in? We're going to put in 12. So whatever is, let's see if we can color coordinate this. Whatever's here, I'm going to put in here. So whatever you see replaced for x here, you can replace for x there. All right, let's figure this out then. So now order of operations, we're not solving for anything, we're just doing order of operations. So it's 12 times 25, which is going to be 300. I'm like, if we have 12 quarters, how much we got? $3. Minus 45, so that's going to be 255. So the way you can write that is f of 12 is equal to 255. All right. And then this one, notice where the number is, it is no longer with the x. This one is going to be for the y. So instead of replacing for the x, we're replacing this for the y. So 145, negative 145 is equal to 25x minus 45. See the difference? And then from here, we're just going to solve for, now we have to solve for, we cannot use like order of operations here, but because we have to solve for something instead of just simplifying. So again, we're going to add 45 on both sides. And what do you get? You get negative 100 is equal to 25x. And if you divide both sides by 25, what do you get? We get x is equal to negative 4. All right, so the way we could write that, oh, my nose. Sorry. F of negative 4 is equal to negative 145. Or honestly, if you just say x equal to negative 4, that's fine as well. Okay, either way is okay. All right. I would, again, practice this, see if you could figure it out. And if you can't, then finish the video. We're going to stop after this one. So here we go. So I notice right here, this is, we're adding by 2 every single time, right? Adding by 2. And here we are we're getting smaller. So it's negative. So it's subtracting how much? Subtracting 12 every time, right? So 6 minus 12. Yep, negative 6. Negative 6 minus 12, negative 18. Okay. So remember, our slope is going to be how much the y changes. So negative 12 over how much the x is changing, which is 2. So if we go down 12 for every 2 we go across, well, how much do we do when we go over 1? Right, it's just negative 6. So we just divide it, right? So that's going to be -6. So -6x. And then what is my 0 going to be? So if x is 0, what's it going to be? That previous term? Well, we just add 12 to this, right? We just do reverse engineer it. So that's going to be plus 12, so that's going to be 30. So if we think about 30 minus 12, does it give us 18? Yeah, it's very good. So this is going to be plus 30. Now, if we take a look at this, well, what would g of -9 be? Well, plug in -9. So -6 times, instead of x, we're going to put in -9 plus 30. And order of operations says -6 times -9, 54. Plus 30, so that's going to be altogether 84. So g of -9 is equal to 84. All right. Now, what will it be if y is equal to -54? Or we should say g of x, right? So if this bottom number right here is -54, what number would that be on the x? So we're going to just plug in -54 for y, or g of x, I should say, and -6x plus 30. Now we're just solving. All right. Solve for x. And if we take a look at this, we're going to subtract 30 on both sides. Why do we subtract 30 on both sides? Because it's to get rid of the plus 30, right? Because what's 30 minus 30? 0. And if we go -6 plus 0, what is that? Just -6x. So that's what we want. We want just the -6x by itself. So this is going to be -84 is equal to -6x. And then we're almost there. We divide by -6. And what do we get? So x is equal to 114, right? So you could write it like this. This is an answer, or you could write it like this. So g of 14 is equal to -54. Either way is okay. All right. I'll see you later. Have a good one.